Hello everyone. In today's video, I'm going to show you some review problems. Okay, so let's directly start the problem. Okay, so look at this problem very carefully. As always, I'm gonna read it first. Okay, in the formula, a equals to I e the power of kt. Okay, this is very important formula right here. Right. So a equals to I e the power of kt. Okay, so A is the amount of radioactive material remaining, okay, remaining from initial amount I, okay, at a given time t, and K is a negative constant, okay. So a human fossil is discovered at a certain place if it has 35% of the carbon-14 it originally contained, okay. What is the approximate age of the fossil? Okay, carbon-14 decays at a rate of 0.0125 annually. All right. So in this problem, we have to be careful and try to sort out the givens first. So in this problem, what's given is the following. Okay. First of all, K constant is given. It is a negative constant. You can see a negative constant negative 0.0125%. This is given in percent, okay? So we have to change this one into a decimal number. When we divide this by 100, because percent means over 100, so this is going to be negative 0.0020. So I have to add two zeros here because when I divide by 100, another 0.125. Okay, this is my K value. Okay, this point was here, and then 1 2, because when I divide by 100, so remember, when you divide by 100, you have to go to the left two decimal places. Okay, so this is it. You can use your calculator also. Okay, well, the other one is, what is the relation between A and I? A is the final amount, okay, after decay, and then I is the initial amount. So when they check this human fossil, they found that A, the final one, is 35% of the original one. Okay, that is 35% of the I. Okay, the I is the original amount of carbon-14, but A is the final amount. But when they check this carbon in this human fossil, they found that A is 35% of the original. Okay, if the original was 100, that means they find 35. If the original is whatever amount, 35% is remaining now. Okay, all right, because this A is the final. What the final means is the remaining part. The initial is the I. Okay, so this is another important point. All right. Also, you have to remember 35% means I can just divide 35 by 100. So this will give me A equals to 0. Right, 35 of I. Okay, the initial one. Remember, I is the initial, A is the final. Okay. All right, then finally, what's left? Well, everything is there now, so I have to go ahead and then solve the problem. Okay, solve the problem. Now solution. Okay, let me solve it. Solution. All right, solution. I'm looking for required. What is required? All right, required, or what I'm looking for. I'm required the time. Okay, if this has 35% of the carbon originally contained, what is the approximate age? Age means just time. Okay, in this question, time is asked as question mark like this. Okay, great. Now what I have to do is go ahead and then write the formula. A equals to I times e the power of k times t. All right, but there is a relation between A and I. It's given here is 35% of I. A is 35% of I. So why I go ahead and then change this A by 35% of I? Well, that is 0.35 of I equals to, in the right side, I e the power of k. K is now given negative 0.000125 times t. Okay, I'm looking for t. Okay, now before I go ahead and then check for t, let me cancel I by I, because from both sides I have I can cancel both i's. Okay, now the next is 0.35 0.5 equals to e the power of minus 0.000125 t. Okay, all right. So now remember, when we have e, to avoid this e, you have to multiply both sides by what? By ln. Okay, the natural logarithm ln. If I multiply both sides by ln, what makes my ln to e is it will cancel e and then it will bring this exponent down. Okay, so that means, okay, I'll get ln of 0.35, okay, equals to, when I multiply the whole thing by ln, what it does is it cancels e and then simply brings the negative 0.000125 t down. Okay, now perfect, this is now very close. Okay, very close. So next is, I'm looking for t. I have to divide both sides by negative 0.00125. So my answer is gonna be t is equal to ln of 0.35, okay, divided by this number right here, negative 0.0000125. Okay, so now I can go ahead and then use my calculator. Okay, I can just show you using a calculator how to solve this one. The ln of 0.35 is something from the calculator we can find. All right, so let's go calculate using the calculator. Sorry, the calculator is gonna take a little bit more. Okay. All right, you have to be patient a little bit. Right, excellent. ln of, very good. Also, let's clear this one. Let's clear this. Let's clear that. All right, look at that. So look, what you have is ln of 0.35. Okay, ln of, you gotta go to the ln right here. ln of 0.35. Close that. Enter. This is the answer, right? See, this is negative. Okay, at the bottom side I have also another negative, if you remember that. Look at that, I have negative 0.003. Okay, 125. Okay, this is divide. Okay, divide by, I can just open the parenthesis, negative of 0.000125. 125. Okay, that answer divided by this one, just go enter. We go 8398. 8398.56. 8398. So 8398 means this is approximately 8398.5 years. Okay, years, because the time was given by years. So we can conclude that the fossil of the human body was about 8,398.5 years old. Okay, so you have to practice on this one and then make sure you understand how to calculate this. All right, number two. Question number two is here. Okay, question number two is a kind of similar problem, but this is straightforward. So you know, in exponent there is decay and growth. So the decay of 920 milligram of an isotope is given by a as a function of time is equal to 920 e the power of minus 0.015 t. Okay, where it is time in years, find the amount left in 60 years. Okay, in 60 years, how much is left? Okay, so this is very straightforward. All you have to do is a of 60, a as a function of 60, or in 60 years, is equal to 920 times e the power of minus 0.015 times the time is given as 60. Okay, I'm gonna include this 60 here. Okay, so as always, what I have to do is, after I have this one, just go ahead and then use your calculator. Okay, go ahead and then use your calculator. So that means I can just go ahead in this one. I just simply can write 920, all right, times e. Okay, multiplied by e is here. Okay, second times this. Oh, sorry. Back. This one, delete that. delete that, second ln, okay, second ln e the power of negative, I'm gonna open the parenthesis. You have to be careful when you have negatives. Negative 0.015 multiplied by just 60 years, okay, and then make sure you close this parenthesis, and then backward, just close the parenthesis, and then move your arrow, and then equals, okay, so this is gonna be 374, okay, the amount is gonna be 374, this is gonna be 374, okay, 374 milligrams, okay, so whatever that isotope, okay, if it stays about 60 years, if originally it was 920, by this rate it's gonna remain 374 milligrams of the isotope. So this is very straightforward, okay. All right, next is about logarithms, okay, about logarithms. So you have to remember the rules of logarithms, and you have to apply that. So let's say, for example, this is solve logarithm of x minus 21 is equal to 2 minus logarithm of x, okay. So the first thing to do about this one is you have to bring the same like terms together. That means logarithm is here, another logarithm is here, just bring that to the left side, okay. So that means logarithm of, right, logarithm of x minus 21, right, plus, because this is minus, it's gonna be plus logarithm of x equals to 2, okay, this 2. Now when I get here, I have to remember, okay, so the rule of logarithm addition, this is addition, so we have to change it into multiplication. That means if we have logarithm of x plus logarithm of y, this is the same as logarithm of xy, okay. This rule is just multiplication rule, so if you look at that, logarithm of x minus 21, logarithm of x is equal to 2. So all I have to do is now just keep one logarithm of x minus 21 times just x, okay. This is equal to simply 2, right. So this is going to be again logarithm of x times x is x squared, okay, this x times x is x squared, minus this times 21 times x is minus 21x, right, minus 21x equals to 2, all right, equals to 2. Now, so this logarithm doesn't have base, so by default this is common logarithm, okay, this is common logarithm. That means I have base 10 here, okay, see the base 10 here is just understood. So what I have to do is remember, if we have, again, you have to remember this logarithm rule, logarithm of, right, x base b equals to y. This is the same as b the power of y is equal to x, okay, this and then this, okay, b the power of y is equal to x, okay. So this 10 the power of 2 is equal to that, okay. So that means, okay, x squared minus 21x is equals to, right, 10 the power of 2, which is 10 the power of 2 means 10 the power of 2 like this, which is 100, obviously. So this will give me what? This will give me x squared minus 21x, okay, this is 100, x squared is 100, and then when I move it to the left side, it's going to be minus 100 equals to